In this problem, we need to determine the equation of a circle such that the circle is tangent to the line given by the equation 2x minus y minus 4 equals to 0. And also we are provided with the coordinate of the center, that's 1, negative 3. So let's try to understand the problem graphically. So here we have a circle whose coordinate of the center is given by 1, negative 3. And we have this another line. So this line is tangent to the circle and we are provided with the equation of the tangent line. So that's 2x minus y minus 4 equals to 0. So using only these two information, we need to determine the equation of the circle. Now to find out the equation of a circle, we need two information. One is the coordinate of the center and the other is the radius of the circle. Now since we already have the coordinate of the circle, we'll have to find out the radius. For that, let us begin. So what we'll do, we'll start with a construction. So what we'll do, we'll consider the center of the circle to be denoted by C. Now from C, we're going to drop a perpendicular on the tangent line. Now, we're going to label this point as, let's call it A. Fine. So our task will be to find out the equation of the line CA. So what we'll do, we have drawn CA perpendicular to the line. Fine. Now we'll start with the equation of the line. Let's denote the line equation with L. So we are working with the line L. So we have 2x minus y minus 4 equals to 0. So what we'll do, we'll try to write it in the slope-intercept form, which is y equals to mx plus c. And from here, we'll try to find out the information about the slope of the line. So let's do that. So we can rewrite this particular equation to get y equals to 2x minus 4. So that means if we compare it with the slope-intercept form, then our slope of the line comes out to be equals to 2. So we have the slope of this line. Now there is a property. The property being, if we have two lines that are perpendicular to each other, then the product of the slope is going to be equals to negative 1. Meaning the product of slope of the line CA times m, which is the slope of the line L. So this product is going to be equals to negative 1. Since we have found out the value of m, so now we can determine the slope of line CA. So CA is going to be negative 1 over m. And our slope m is 2. So slope of line CA is going to be negative half. Now that we have the value of the slope and we also have the value of one coordinate point C, we can find out the equation of line CA. For this, we'll have to use the point slope form. The point slope form states that if we have, let's say, a point which is x1, y1, and through this point, let's say a line passes, and this line has a slope m, then the equation of this line is given by y minus y1 equals to m multiplied to x minus x1. Fine. So that means what we can do, we can substitute the value of x1, y1 with the coordinate given in C, which is 1, negative 3, and our slope is negative half. So we get the equation of line CA. So we'll get equation of line CA. So that comes out to be equals to we have y minus y1. So y1 is negative 3. So that's equals to the slope, which is negative half multiplied to x minus x1. So x1 is 1. So let's now solve this. We get 2 times y plus 3 equals to negative x plus 1. So we have 2y plus 6 equals to negative x plus 1. Or we get x plus 2y plus 5 equals to 0. So this is the equation of line CA. Now we found out the equation of this particular line CA, so that when we solve the two equations for CA as well as for line L, then that is going to give us the intersection point A. This is our next task, to find out the intersection point A. So all we have to do is solve for x and y using the equation for line L and equation for CA. So CA came out to be x plus 2y plus 5 equals to 0. Plus 2y plus 5 equals to 0. So let's do that quickly. That's a very simple problem. So we have 2x minus y minus 4 equals to 0. We're going to label this as equation number 1. And then we have x plus 2y plus 5 equals to 0. We're going to label this as equation number 2. Now we'll use the method of elimination. So we'll take equation number 1 and we're going to multiply with positive 2. So this is going to transform into 4x minus 2y minus 8 equals to 0. And then we'll take equation number 2. So this is going to become x plus 2y plus 5 equals to 0. So we get 4x plus x, so that's 5x. 2y and negative 2y cancels out. Negative 8 plus 5, so that's going to be equals to negative 3. So that's equals to 0. Solving for x, we get 3 over 5. So now that we have the value of x, we can either use equation 1 or equation 2 to obtain the value of y. So let's use equation number 1. So that means we have 2 times 3 over 5. So we have substitute the value of x with 3 over 5 minus y minus 4 equals to 0. And when we solve for y, we get the value. Y will be equals to 6 over 5 minus 4. So that gives us, so we have 6 minus 20 over 5. So 6 minus 20 is going to be negative 14 over 5. So this is the value of a y coordinate. So now that we have the x and y coordinate, so that means we also have the coordinate point A. So let's note them down. So we have a coordinate of the point A. So that's x coordinate is 3 over 5 and the y coordinate is negative 14 over 5. So we're almost there. Now we have the coordinate point of A as well as the coordinate point of C. We can use it to find out the radius of a circle. What we have to do is use the distance formula. So using the distance formula, we can easily obtain the radius of a circle. So the distance formula, that's very simple. It's simply r equals to square root of. So we'll have to take the difference of the x coordinate. So we'll take 1 minus 3 over 5 and then square it and add it to the square of the difference of the y coordinate. So that's going to be negative 3. So we have negative 14 over 5. So we get positive 14 over 5 whole squared. Solving for the value of r, we get r equals to 1 over square root of 5. Now we have the radius and we have the coordinate of the center. What we can do now is use the standard form of a circle to find the equations. So let's state the standard form of a circle. So the standard equation of a circle states that if we have a circle whose coordinate of the center is given by h comma k and the radius denoted by r, then we have the equation x minus h whole squared plus y minus k whole squared equals to r squared. That gives us the standard equation of a circle. Now in our case, we have obtained the center, which is denoted by h comma k. We found out that this is already provided to us, so that's 1 comma negative 3. This immediately gives us the value of h and k. So h has the value 1 and k has a value of negative 3. And we calculated the value of our radius of the circle. So that's 1 over square root of 5. Now we will substitute all the value of h, k and r that we obtain into the standard form, and that gives us x minus 1 whole squared plus y minus of minus 3. So we get y plus 3 whole squared, and that's going to be equals to 1 over 5. So this is going to be the standard equation of the circle in its standard form, and if you want, you can also expand it. Rather, I'm going to leave it as an exercise for you to try out.